Okay, good morning everyone. I'm Francois Roberge from Matrox Video, and we'll talk about what is IPMX. We'll do a quick technical overview. We'll go quickly to some origin and goals of IPMX. Some have already been discussed this morning, but we'll quickly go through them. Then we'll dive into this technical specification. Of course, there are 14 documents, so we won't go through each of them in details, but we will do a good overview and highlight the most important things for you. And we keep a bit of time at the end if we have some question. Okay, let's start with what is IPMX. It stands for Internet Protocol Media Experience. It is an AV over IP transport, discovery, and control protocol. Like it was said before, it is aimed at the Pro AV market, but it takes its roots into the broadcast technology. So IPMX did not reinvent the wheel. It took all existing technology proven to be working in the broadcast world and bring it into the Pro AV market by adding some features to make it more user-friendly and lower the cost of implementation. It allows to be low latency, high interoperability, and low cost, obviously. So basically, with IPMX, you can take any type of audio, video, multimedia content, even metadata, and stream them onto your IP network, each being their own IP stream flow. Video, audio, metadata are independent. Video and audio can be in compressed or uncompressed format. And once it is on your network, you can route this to any destination you want. And the very cool thing, one I like most about IPMX, is the NMOS. NMOS is mandatory. It's the discovery and control part of IPMX. So any device you plug onto your switch just says, hey, I'm here, I'm an IPMX device. So here are my capabilities. It gets registered into the database. And after that, you can use a web interface to go and control your routing. It's pretty cool. In IPMX, like it was said earlier, PDP is optional. It was often claimed that PDP is complex to use. In IPMX, if you don't need PDP, just don't use it, it will work. If you want to use it, you can still. IPMX also provides HDCP encryption. So if you have HDMI content, you want to keep your content protected through the network, IPMX allows that. And we also added the privacy encryption. So if you have an SDI source or any metadata you want to encrypt, we have mechanism to do that as well. The main component of IPMX we'll talk about are RTP transport, HDCP protection, forward error correction, discovery and query protocol from AMWA and MOS, control from AMWA, and aided management also from AMWA. VSF is the working group documenting and redacting the specification. The specification is called TR-10, TR for technical recommendation, and I like to say 10 for the 10 good reasons to love IPMX. The very key point is that it's an open standard, free of charge. You can have access to all documents from the VSF website. There's only maybe fees that will apply for certification later, but today there is not even a need to register and enter your email, so you are guaranteed to not get spam or any digital harassment. You can download it, read it, it's totally free. And for those who might know, VSF were also the originator of the SMT 2110 specification before it was taken over by SMT. Okay, let's dive into the detail now. TR-10 is divided into multiple subparts, just like SMT 2110. The first start point, if you want to dive into the spec, is TR-10-0. It is briefly an index that's describing all the document, all the spec, and what their content is. So that's the very good start point. The next important thing is TR-10-1. TR-10-1 is the equivalent of SMT 2110-10. It is the foundation of the technology. It talks about the synchronization SDP file, all devices can play nice together. So that's really the foundation. And for the rest, all the documents are very similar. They are built to highlight which part of third-party specification are used, how to use them, and they make reference to TR-10-1 instead of SMT 2110. So when you go and read some part of SMT 2110 spec, because IPMX says you use this part of the spec, then you need to remember to refer to TR-10-1 for timing information, not to refer to SMT 2110-10. 14 spec available today. TR-10-2, 3, and 4 are for audio, video, ancillary. They are the equivalent of SMT 2110 specification. We added TR-10-5, which is HDCP, TR-10-6, which is the forward error correction, strongly based on SMT 2022-5. We have TR-10-7 for video compression, and also TR-10-11. So one is for constant bitrate codec, one for variable bitrate codec. TR-10-8, it's the NMOS requirement, so the basic that needs to be supported to be IPMX compliant. TR-10-9 is it's general guidelines how to build your system and how your device should behave to play nice with everyone on the network. So it's a very interesting specification. It's still in draft, but it is very interesting to read. TR-10-10, it's for HDMI info freight packets transport. -12, transparent audio. People were asking about compressed audio. Yes, it is supported. TR-10-13 is the famous privacy encryption, and -14 support of USB for KVM as example. Now, enough with all the document. Just jump into the technical things. The first big thing is that in IPMX, PTP is not mandatory. So if you have PTP on your network, the devices are supposed to use it. They must use it to synchronize their local clock, and it will work just as well as in 2110. If you don't have PTP or don't want to have PTP to lower your cost to get a simple system, then you can do it, and IPMX provides alternate methods for synchronizing the device. The second thing IPMX does differently than 2110 is that it natively supports asynchronous signal. In 2110, everything is synchronized with PTP and SMT 2059, so knowing that it's January 1st, 1970, midnight, the vsync of every resolution was launched and still running since then very precisely, you can, with a little mathematical formula, knowing the time of the day, predict that the next frame will occur in 12 milliseconds. Now, in IPMX, we say we have a lot of HDMI sources that are asynchronous, so we don't care about that. If your video is shifted by half a frame, we accept it, it will work, we provide the mechanism for that. And this famous mechanism is the HDCP sender report. It is again something not new. It was existing since a long time in the internet world. It's governed by RFC 3550. So basically, it's just a little packet of information that says, hey, it was this time when I sent this packet with that RTP timestamp. It allows the receiver to know a bit more about the clock of the sender. This packet is sent every 10 milliseconds for audio information, and we send it before every frame for video stream. So it is really reliable. We have constant stream of information about the sender timing. So to not alter the media stream and stay compatible with SMT 2110, this information is sent at the same IP address that your video flow, but using a different UDP port. So a SMT 2110 receiver will be able to receive your video stream and will just ignore that extra packet sent at a different UDP port. So the packet looks like this. It contains the timestamp. If you have no PTP, you will put your local clock time there. If you have PDP, then you will put your PDP timestamp, PDP local time there. And of course, there is the RTP timestamp of the packet as well. Okay, another difference between IPMX and 2110 is the traffic shaping. In 2110, since there is PDP and traffic is more tight on the network, we expect to see packet be transmitted fairly regularly. 2110 also provide a provision for software sender, so they call it the wide profile. So you can have device sending packets with a bit of jitter. It is supported. But in IPMX, we wanted to make it more friendly for jitter on the network. So we did something that to relax those constraints. Those who are familiar with 2110 will likely recognize this big blue cylinder, which is called also the VRX buffer model. In 2110, the rule is that the receiver will start to use packets from its buffer at a very fixed time based on the PDP time. So no matter if your buffer is full, empty, you have to use the packet. In IPMX, it was relaxed, so the receiver will start using the packet when the buffer is half full. So it leaves room. If you have a jittery network, you can compensate both ways. So IPMX, no fixed relationship between the timing of the PDP and the timing of the sender and the time the receiver starts to remove the packet. And it's more friendly for wide sender. A bit about the receiver timing. Like we saw in 2110, everyone follows PDP, everyone is well synchronized. In IPMX, a receiver has the capability to reproduce the timing of the source. So not based on 2110, but based on the original asynchronous timing of the source. So if your source is shifted in time compared to PDP, normally a 2110 network will realign the video stream on the PDP. In IPMX, the receiver will just keep the video stream as close as possible to the source timing and will replay at the output, let's say a few lines after you receive the video stream. So this is allowed and possible to do in IPMX. So it can reduce the cost because you don't need to buffer or to do a frame rate conversion or whatever, or to realign your output. You can just replay it as soon as you get the information. Final point in TR-10-1 is the SDP file. Like in SMT 2110, the same SDP file is used. We add an IPMX tag to identify that we are using IPMX devices. And we add two important information, again for timing and synchronization. We list the exact measured pixel clock and measured sample rate of the sender. So let's say that you want to send 60 Hz video. In practice, because of the component and the precision of your device, you might be sending 60.0001 Hz video. So IPMX says in the SDP file, you have to say the real clock you are using. So you will say 60.0001 Hz. That will help the receiver to recreate your timing. Okay, so we did the most complex stuff so far. So we'll go through the remaining 13 documents in the next 20 minutes. So we'll go a bit faster. There are less changes. They are more similar to the original SMT 2110 spec. So for video, it is basically the same thing, except that RGB support is mandatory in IPMX. So you have the same IP stream, same video packets, everything is the same that is in 2110, but RGB is mandatory to be supported. And the second thing, very important, is the HDCP sender report. So it's the same packet used to convey timing information, and we can extend that packet to put description of the media into the packet. So That was a big complaint in 2110. People were saying, I received a stream, I don't know what it is. I know it's video, it's supposed to video, but is it YUV, is it RGB? I don't know. I have to go to the SDP file to know about it. So in IPMX, we fixed that, and we add this information into the video stream. And again, it's in the same RTCP sender report, so it is sent at the same IP address than the stream, but at UDP port +1, so it does not interfere with the native video stream. So if my video feed is 239.10.2030 UDP 6000, then my RTCP sender report is at same address, but using UDP port 6001. So the info block extension look like this. So there is a part that describes the color space, resolution, HDR format, or whatever you like to put in there. And a very cool thing for implementers is that to avoid a receiver having to parse the packet all the time to know if there is something that will change, there is a counter in the packet header. So whenever the sender changes one parameter, let's say resolution or color space, it must increment the counter value. So the receiver just needs to check the counter value in the packet and knows if it has to parse the packet to detect the change, or if, I will just ignore the packet, nothing changed. I have still the same resolution, same color space. Okay, let's go to a practical example. So let's say that today here I'm doing a presentation with my cheap laptop, supporting only HD resolution. I plug my HDMI out into an IPMX transmitter. It starts to stream. We go through the use of SDP file exchange, so the transmitter can tell the sender, this is my resolution, these are my capabilities. I am RGB, 60 Hertz, HD, and we establish the network path and image appear on screen. So we remember that on the network, I will have my video stream and the little RTCP packet with media information. Let's say that someone with a high budget comes just after me and have a fancy laptop supporting 4K. What's going to happen? Don't worry. There is no need to go through all the XDP file exchange again, because when the unplug plug will happen, the sender will detect the new resolution. It will modify its RTCP sender packet information that will flow along the data, and the receiver will receive the RTCP packet before the video frame. It will adjust its parameter, and you will have a switch directly and fast on UHD format at the output. So no need for user interaction. The format information goes along with the video stream. It allows a faster switch than going to retransfer the SDP file once again. Okay, digital audio now. Basically same as 2110, except that 2-channel 48 kHz 16-bit and 24-bit is mandatory to be supported. Again, same thing that for video, RTCP sender report are used to describe the video flow on the network, say how many channels, what's the frequency. So same thing as for video, RTCP sender report are used. Ancillary data, for those familiar with SDI world, it's still supported, very similar to 2110, except that there is a clause recommending or discouraging people to use old stuff and to transmit embedded audio packet, embedded audio control packet, and stuff like that. So IPMX is a new standard. It's going toward the future. So we discourage using all old information, but if you need to, you still can. TR-10-5, HDCP. So once again, this is a specification coming from a third party. IPMX only says how to use it and which part apply. And it allows you to keep your HDMI content protected on the network. So it basically tells you how to establish a TCP/IP link to exchange a key between your device and make sure your content stay protected from source to destination. It is almost seamless to the user, and one cool thing for implementers, if you have device with multiple IP HDMI port, let's say it that way, you can reuse the same key for all your IP port to avoid complexity of development and extra key to be bought. Forward error correction. This is optional. It's targeted for low latency and low overhead. It supports video codec that are variable bitrate. So it's there if you need it, good. Some people were using redundancy in 2110. You can still use redundancy, but if you don't want to, forward error correction is there for you. And it can protect against 2 packet loss per 32 packet. About 6% of the packet loss is protected with that error correction. There is a profile for high bandwidth, like video, and one for lower bandwidth, like audio signal. Compressed video, I will not talk too much about that because my colleague will do a presentation later on this. But just let's say that it supports compressed constant bitrate and variable bitrate. So H.264, .265 are intended to be supported. And once again, HDCP sender report can be used to add information about your compression format. NMOS requirement. So as we said before, NMOS is mandatory to be supported by your device if you want to be IPMX compliant. IS-04 version 1.3, discovery and registration is mandatory. It uses DNS-SD or multicast DNS to discover the server on the network. And IS-05, which is the control and connection management part, is also mandatory. And that makes it very, very user-friendly for anyone. No need to add a fancy engineering team to set up your network. So someone in the Pro AV world at a bar wanting to distribute video content to 8 screen can set up his network himself very easily. TR-10-9, and this is the special spec. It's more a general recommendation when you want to build a system. So it talks about stuff like network requirement for HDCP, IPv4, IGMP. It gives some example about the quality of service of your network and how to properly synchronize video and audio based on timestamp. Very interesting if you are building network. TR-10-10, HDMI info frame packet. In HDMI, there is the equivalent of ancillary data that is called info frame. So IPMX allows you to support that as well. And once again, to not alter the video flow, we send the info frame stream using a same IP address but a different UDP port. So it is easy for the receiver to recover the information. It doesn't bother 2110 device if they don't want to use it. And this kind of capabilities is obviously described in the SDP file. So as we can see, using TR-10-5 HDCP, TR-10-10 info frame, and idiot management from IS-11, you can make your IPMX network just behave like a HDMI cable from end to end. So it will recreate the timing of the source with a bit of latency, but it will not necessarily introduce 1 frame or 2 frames of latency. It may introduce only a few lines of latency between your sender and your transmitter and your receiver, and you will still have access to the info frame, to the HDCP encryption, so it really behaves like an HDMI cable if you want. TR-10-12 AES audio, yes, it is supported with compression. Again, RTCP sender report are used to describe the stream, and the requirement is to support 48 kilohertz. So all the rest is very, very, very similar to 2110. The new kid in town, TR-10-13, that's the privacy encryption. So it allows you to encrypt anything you want with your own key. So if you have transmitter and receiver device with key pre-stored in them, so you can keep your content secure. It is very, very useful when you want to build a KVM solution where your keyboard is at one end of the building and your PC at the other end. Of course, you want to keep your password encrypted, so you can use privacy encryption. It can encrypt video, audio, metadata. So TR-10-13 explain to you all the details about that. And finally, -14, USB support for KVM, obviously. But not only, it is supporting USB 2.0, so any USB 2.0 device you plug will be transported with IPMX. Can be a USB key, USB camera, microphone, whatever. It's really USB 2.0 that is supported. And again, it can be encrypted using privacy encryption protocol. That's it for me. Any question? Yes?
For the HDCP method, is it something validated, agreed by DCP?
Yes, it reused their specification. They have a specification for DCP over network existing for years. So IPMX basically says, use that specification. So we didn't reinvent anything, we just point toward that specification. That's it. Thank you very much.